Microphone. Here we go. Hi, peoples. I gotta attach my mic, so excuse all the crackling. Math Avengers, greetings, salutations. Can you hear me okay? Yes, no? Ah, I better type this in. Can you hear me? Please respond in the chat. Oh, man. Oh, awesome, awesome, beautiful. Okay, good, 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 good. Ah, okay, dokie. So, I'm looking at this thing right now also on my cell phone, so I get an idea on my smartphone, so I get an idea as to what the uh, as to how much of the screen you can see me writing and how much of the screen you can just see me talking. And I'm kind of thinking I need to enlarge this so that I show up a little bit better. I mean, the writing shows up better. My face is a blur. Yeah, you know what? The camera is not so hot. Uh, Still working on the tech. Okay. I'm actually going to take my face out of this and so that you can see the full screen will be the whiteboard. So let's do that right now. And that should look a little bit better. Um, okay. So we're live streaming, and I will also put this up later so that you can watch it in review. Uh, you can you can see the reruns. What we're doing is a uh, is we're going to calculate this shaded area here. Now, can you see this okay? Yeah, it looks like it's got covered. Um, okay, so the idea is we're calculating the shaded area, and I call it an infinite batwing because it's has these little bites that go on and on and on and on and on forever, and it comes to a point, except on this on the bottom these little lumps just get infinitely smaller, and on the top it's a nice sine wave. So what do we have here? We've got uh, let me just bigify this. Okay, so what do we got here? We've got this right along here. Okay, that function is just sine x. Okay, so up here it that's it goes up to 1, it goes from 0 to 1, in the vertical, and then in the horizontal, let me move this a bit here. Actually, you know what I should do is I should draw the axes here. This is really okay. So 0 to 1 in the vertical, and in the horizontal it goes from 0 to 0 to pi. Okay, and then this next one is half that size, so it's going to go to 1/2, and right here, this space right here, that's going to be pi by 2, and then it continues. So the next one is 1/2 of sine of 2x, and the next one is 1/4 of sine of 4x, etc., and so forth. So this number here down here is always going to be the same as that number there. Okay, capiche? We're all good with this? I have to go. I need more. Thank you, sir. Thank you, Ayush Thakur. I appreciate that. I like the appreciate the encouragement. Um, one of these days, I'll splurge and get a couple of screens here, so I don't have to keep on going back and forth between the chat and the talking here. Okay, let's hang on. I got to close that. I got too many things that I really distracted. Um, okay, so let's do this. So yeah, I mean, first of all, let's forget all the interesting parts, okay, and let's just do this sine wave here. So we've got from here to here, and we've got a sine wave. Okay, so that goes. So that's one here. That's zero here, and sine x. So it goes from 0 to 2 pi, and there's pi there. What is this right here? Right? And to do that, I'll even shade it so that we can all see how beautiful it is. To do that, we'll integrate between pi and 0, uh, sine x dx. And I got this. I forgot the negative sign before when I did this previously. There was on my one of my smart alecky videos where I moved the where I was just moving letters around and just goofing around, and then I ended up actually getting the right thing wrong. Okay, so antiderivative of sine x is negative cosine, put a little equal sign, negative cosine of x. I got that right? I think I got that right. And it's evaluated between pi and 0. So that's going to equal negative cosine of pi um, minus negative cosine of 0, which equals, I love it. You still have to remember what 1 plus 1 is. It's all modular, eh? So that equals 2. Okay. So if we didn't have the whole Batwing thing going, excuse me, if we didn't have the whole Batwing thing going, we just had the area underneath the sine curve, that area is 2, which, you know, I don't know about you, but isn't that awesome? That's all I can think of. I mean, the area is not only is it rational, but it's an integer. Uh, that just tickles me. Okay, now here here's the thing. Now the next part is the part where you you know you knowing too much can make this harder because the the, the next part of this. Let me go back over here. Oops, I didn't want to do that. Yeah, the next part of this. Let's go back over here, and we'll look at another one. Okay, now and let's now think. Let's suppose we've just got this part of the curve right here, and we're going, okay, so what's the area of this bit? And if we were going to add up all the infinite, take out all the infinite bites out of it, we'd go, we might go, well, that's 1/2 of sine of 2x. So let's just integrate that between pi by 2 and 0. And absolutely, and this would be a way to check what I'm going to do, which I did this when I was preparing this. But there is what is, in my opinion, a cooler way to do this. And that is to realize that, hang on, I got to slide it over here. You remember that that's 1 for the rate for the sine. The sine one, sine x goes up here to 1. Okay, but everything is cut in half for this next half sine wave. That's one half, and that's pi by 2. So it's all scaled down by one half, vertically and horizontally, which means that the x the x is scaled by one half, and the y is scaled by one half. So one half times one half equals one quarter. So this bit right here, lovely. This is very satisfying doing this. I don't know if you can pick up the sound, but it's sort of ASMR-y. One half times one half is one quarter. So this little bite out of here is going to be one quarter of the of the larger hump, the other larger wave. So one quarter of two, which is one half. Okay, so without going and doing the integrating, not that it would be terribly difficult, but without going and doing that bit, just by scaling down the larger one, we know that this is one half. And I want to pause that here because this is not a good place to lose people, but it might be where I might lose somebody. So if you could just give me some feedback, do you see that, folks watching that how that would be is a quarter of the size of the other one? Just give me a thumbs up or say something in the chat, please, so that I can see what you're talking about. I can see that you know. Just means you. I gotta grab myself some coffee here. Hang on. Ah, I'm gonna assume you catch it. Ah. Also, I'm curious what kind of device people are using because it helps me know how this makes uh, how this looks here. Hi, Carter Woodson. Um, so if you want to mention in the chat too what kind of device you're using, so I kind of know what I'm catering to, whether I'm dealing with big screens or little screens. I'm looking at it on a little screen and it looks like over here and it looks like it's all seeable. So anyway, um, now I got to move on here. Mobile phone, okay. Math Avengers, does it look okay on the phone? Carter, oh yeah, most of the people watch this on the phone. So if there's anything I can do to make it clearer or help you see it or hear it, and give me the feedback. Be cruel. Let me know. Um, Otherwise, I'm going to move on here. So this thing of cutting in half and cutting in half and cutting in half, we're going to do that forever. And we could do a we could do probably a geometric series like this. And I think this is actually where I got this. I think, what was it, Bind Your Decisions or somebody, or Presh Talwalker, he had a thing where he had a square with a circle, and then it kept on going on forever. And he goes, well, okay, calculate this. And there's a couple of approaches to that. I think he did the approach where you do it as a infinite geometric sequence. There's another way to do this, which really it's the same thing. I mean, it's the same thing. It's just looking at it a different way. And here's what I'm going to do. Um, I'm going to go down here. As you can see, I prepared a whole bunch of these. Okay, and I'm going to say, okay, well, what if? And to do my what if, I'm going to actually get into the white. You see this right here, and let me give it a different color now. I'm going to color it like this. This thing right here, it's a miniature version of the whole problem. Okay, It's like say we do that same thing when we're doing these infinite fractions, infinite square roots, and stuff like that. Okay, this right here is a miniature version of the whole problem. So if our solution, like if this thing down here, if we want to call that x, okay, we want to say that area is x, then this area here is a quarter of x, because remember, everything is scaled down by 1/4. Okay? Okay. Hey, I have to look at my notes. Okay. So now we ask, and I'm going to use I got to use a different color here. Hang on here. What's a good color? Blue. I like blue. Okay. So this right here, and back to black. This right here, what I've left, what is it? It's that whole lump, which we worked out to being having an area of 1, okay, less this this area here, so minus 1/2 minus, because what I'm just interested in kind of this shape here, okay, so that's gonna be minus another half, and gotta do this without a calculator. I've got students who would like grab a calculator for stuff like this. I'm sorry, I should. Okay, you feel especially if you're writing a test. I think I would probably do this too. Okay, so this area here, with the sort of that shape, that's got an area of 1. Okay, but the whole thing is x. Okay, so that means that this area here is 1, and this bit here, this smaller version of the infinite thing, is a quarter x. So that means that the whole thing is x equals 1 plus 1/4 x. And now we get to solve for x. Hi, Beryl. You missed the channel. My volume is full. Then turn the volume to full. Are people having a hard time hearing this? You just let me know, because I'm trying new things with the microphone. Okay, and so you just give me everything, and because we gotta make sure that this works out to people, because I'm just about done here, and then just let her rip in the comments if there's things that need to happen to improve this. I mean, there are things. Just tell me what they are. Okay, so now we're looking at x. X equals 1 plus 1/4 x. So that means x minus 1/4 x equals 1. So 3/4 of x equals 1. So x equals 4/3. And we are done, to quote our good friend Blackpen Redpen. That's it. I did a bite-sized thing. I'm kind of impressed with myself, because usually I set up something. Let's do Fermat's last theorem or something like that. I set it too big. That is it. That is the solution. X equals 4/3. Question for you all in the chat. Let me bring this up here. I'm gonna change it a bit here. Did anybody try this ahead of time? Louder will be better, but I understand everything so far. I need help. Yeah, I got to figure out the tech. Awesome. Thank you. Thank you for saying so. Did anybody try this? Did somebody get a different solution? Did anybody get a different method? Now I can see myself. My hat looks just. Oh, anyway, off goes the hat. Otherwise, we're gonna call it a day. We're gonna keep this a short. We'll keep this a shorter video, and that's. I'm sure I have something wonderful to say that I'm just missing. But thank you so much, everyone. Shout out to everybody: Carter and Burl, Math Avengers, and Ruby, pick. With the headphones, can you hear me okay? That's the question. Earphones, earphones. Oh, you said I don't hear anything. I hope you can hear me now. I have 1,000 plus subscribers, but why so less viewers? You know what? You always get that. It's all cool. All righty. Okay. Okay. Thank you, folkses. And you can continue. I'm going to keep this up so you can comment about it. Any questions about it? I've got one question I don't know the answer to yet. Okay, but something that we could tackle next is what is the length of that infinitely decreasing curve? What is the length of that curve? Um, that's something I was thinking about last night as I was going to sleep, which is why I didn't go to sleep till about 1:30 in the morning. Otherwise, thank you so much, and we are